Hello, Mrs. Raymond here in the Science Corner this week, and we have been studying force. Our TEAC 4.6D says, I can investigate the effects of force on an object. And today we're going to be studying a force called gravity. There are many types of forces in the universe. We have gravity, we have magnetism, and we have friction. Unbalanced forces cause motion. So if there is more gravity than friction, then something will move. Like I said, today we're going to be focusing on gravity. Gravity is the force that all objects have on each other. The force of gravity attracts objects to each other. The strength of gravity is related to the mass of an object. More mass means more gravity. Less mass means less gravity. The sun's enormous mass, because it's very big, so therefore it has a lot of gravity, keeps all the planets and other objects in the solar system revolving around it. Earth's gravity exerts a force down towards the center of the Earth. So it pulls everything down toward the middle of the Earth, including this poor girl who is trying to roller skate and it looks like she's going to fall and probably get skinned knees. Earth's gravity holds the planet together and keeps everything, including you, from floating off into space. Describe a time when you have fallen down. What caused you to fall? What direction did you fall? Pause the video for 1 minute and talk with your partner. All right, now that you're back, the farther an object is from the center of the Earth, the less Earth's gravity affects it. That's why this space station doesn't crash back down to Earth. It's far enough away, the gravity cannot pull it down. In the space around Earth, gravity holds satellites in orbit, including the moon. The moon is much smaller than the Earth, so it has much less gravitational pull towards its center, but the moon's gravity actually exerts a force on the Earth's oceans to create tides. It pulls all the water in the oceans from one side of the Earth to the other side of the Earth every day, a couple times a day. Weight is a term commonly used to describe how much gravity is being applied to a particular object. When we use a spring scale to measure an object's weight on Earth, or a scale like the one that lady was standing on, then we're measuring the force of gravity pulling the object down towards the Earth's center. You experience a greater gravitational pull on the Earth than on the moon, so you weigh more on the Earth. Because remember, the moon is smaller, so it has less gravity. And if there's less gravity, then you are not going to weigh as much. On the moon, you could jump about 2 meters up in the air. 2 meters is 6 feet. That means you could jump taller than Mrs. Raymond, 6 inches taller than me. So think about this with your partner. The surface of Mars has less gravity than the surface of Earth. If you weighed 85 pounds standing on Earth, would you weigh more or less standing on Mars? Explain your thinking. Go ahead and pause the video and talk with your partner for a minute. All right, now that you're done talking with your partner, you simply must know gravity is a constant force. It never stops, and it pulls on all objects equally. Without air resistance, gravity would pull all objects to the ground at the same speed. But you see this is very flat, so the air actually pushes up on it while the gravity is pulling down. That's what air resistance is. It's when the air pushes on things. Air resistance causes friction, which slows down some objects. It says more friction and less friction. Okay, so the shape of certain objects provides more friction from air resistance. So if there's more friction, it won't move as fast. That is why a sheet of paper takes more time to hit the ground than a stone dropped from the same height. Gravity is a powerful force, but it can be overcome. And here you see these knives and stuff, and they're on a very strong magnet. So the force of the magnetism is stronger than the force of the gravity. Thank goodness, or those knives will be falling all over the place and somebody could get hurt. The magnetic force between a paperclip and a magnet is stronger than the force of gravity on the paperclip. So if we get this magnet close, because this looks pretty strong, it's going to make the magnet go up. Let's see. Just like that, because the magnetic force is greater than the force of gravity. So magnetism overcomes the gravity and allows the magnet to lift the paperclip. Huge airplanes use force and lift to overcome gravity and fly through the air. Okay, so that is all we have for today. Please be sure, ladies and gentlemen, to finish the exit ticket. There's a few questions for you to finish in an assignment on Schoology. Thank you very much, and we will see all of you again tomorrow.